Hello everyone, I am PayalSaluja, a student of the EPGP Data Science program at IIIT Bangalore via Upgrad. Today, I am excited to delve into a fascinating problem in a data analysis, finding two elements in a list whose sum is closest to zero. Let's explore how we can efficiently solve this problem using various techniques. Agenda: understanding the problem statement. We will start by figuring out what the problem is all about. We will break it down and make sure we understand it clearly before moving forward. Solution approach explanation. Next, we will talk about how we plan to solve the problem. We will explain our approach step by step so everyone can follow along easily. Data structure. Then we will discuss the tools we will use to solve the problem. We will talk about the types of data we will work with and how they help us find the solution. Solution evaluation, fast and efficient. After that, we will look at how fast and efficient our solution is. We will see if there are any ways we can make it work even better. Python implementation coding. Now we will get into the fun part, writing the code. We will actually write out the solution using Python code so you can see how it works in action. Conclusion. Finally, we wrap things up. We will summarize what we have learned and talk about final thoughts we have about the problem and our solution. Understanding the problem statements. Given a list of integers including positive and negative numbers. Objective: find two numbers whose sum is closest to 0. Example: in a list -8, 10, 5, 1, -4. In this list, -4 and 5 have the closest sum to 0. Key points. Consider the absolute distance from 0. The problem at hand involves finding two elements in a list which may contain positive and negative integers such that their sum is closest to 0. We need to consider the absolute distance from 0 while finding the closest sum. Let's break down the problem further before moving on to the solution approach. Solution approach explanation. To tackle this problem, we will explore two main approaches, the brute force method and the optimization method. The brute force approach involves iterating through each pair of elements in the list and checking for the closest sum. On the other hand, the optimized approach leverages sorting and two points technique for a more efficient search. Let's delve deeper into each approach. Brute force approach. In the brute force method, we iterate through each pair of elements in the list and calculate their sum. We then track the pair with the closest sum to 0. While this approach is straightforward, it becomes inefficient for larger inputs due to its time complexity. Optimized approach. The optimized approach starts by sorting the list of integers followed by using two-pointer technique. These pointers travel the sorted list efficiently identifying pairing with the closest sum to 0. The method offers a time complexity of O n log n, making it more suitable for larger dataset. Next come to the time complexity. Comparing the time complexity of both approaches, the brute force method has a complexity of O n raised to the power 2, while the optimized approach based a better complexity of O n log n. This highlights the efficiency gains achieved by leveraging sorting and optimized searching techniques. Python coding question. Let's apply our understanding to a specific Python coding question. You are given a list that contain positive and negative integers. You need to find two elements such that their sum is closest to 0. For example, you are given a list of -4, 7, 6, 2, -5. The two elements with the closest to 0 will be -5 and 6. Python implementation coding. We will now dive into the Python implementation of the problem. We will explore both the brute force and optimized approach, providing insights into their workings. Let's break down each function step by step. Method 1. Brute force approach. Function 1 closest to 0 blue 1. Initialization. Initialize closest sum variable to positive infinity and result variable to an empty tuple. These variables will be used to tackle the closest sum and the corresponding pair of elements. Nested loops. Use nested loops to iterate through each pair of elements in the input list. The outer loop iterates over the indices of the elements and the inner loop iterates over the subsequent elements. Calculating sum. Calculate the sum of the current pair of elements using their indices obtained from the loops. Store the absolute value of the sum in the current sum variable. Now, updating closest sum. Compare the absolute value of the current sum with the absolute value of the closest sum. If the current sum is closer to 0, then the closest sum seen so far update the closest sum and result variable with the current pair of elements. Return result. After iterating through all pair of elements, return the pair of elements stored in the result variable, which represents the pair with the closest sum to 0. Method 2. Optimized approach. Function 2. Closest to 0. Optimize. Nums. Sorting. Sort the input list of integers nums in ascending order using the sort method. Sorting the list allows us to efficiently perform the subsequent steps. Two pointers techniques. Initialize 2 points left and right pointing to the beginning and end of the sorted list respectively. These pointers will be used to traverse the sorted list towards each other, allowing us to efficiently find the pair with the closest sum to 0. Iterating through list. Use a while loop to iterate until the left pointer is less than the right pointer. Within the loop, calculate the sum of the elements pointed by the left and right pointers. Updated closest sum. Compare the absolute value of the current sum with the absolute value of the closest sum. If the correct sum is closer to the 0 than the closest sum seen so far, update the closest sum and result variable with the current pair of elements. Moving pointers. Move the pointers towards each other based on the value of the current sum. If the sum is negative, increment the left pointer. If the sum is positive, decrement the right pointer. If the sum is 0, return the pair of element as it is the closest possible sum to 0. Return result. After traversing the list with the pointer, return the pair of elements stored in the result variable, representing the pair with the closest sum to 0. Edge cases. Empty list. Handle the case where the list is empty by returning an appropriate value, like none or an error message, depending on the requirement. List with only one element. If the list contains only one element, there are no pairs to consider. So we may return none or the single element itself as a result. Conclusion. The optimized approach provides a faster solution by leveraging sorting and two pointers technique. Time complexity analysis helps us understanding the efficiency of each approach. We explored two approaches, brute force and optimize, and compare their efficiency. Depending on the size of the input data, choosing the appropriate approach is crucial for the performance optimization. Thank you and have a great day.